All right, so let's keep going with some substitution practice. And so we've been working on solving systems with substitution. And as you know, that means we have to get either an x equals or a y equals. That's step one. So let's start by taking a look at this first problem. And do you see a 1x or a 1y? Well, if I look at the first equation, I see a 3, and a 3, which is important because that tells me I could actually solve that equation for an x or a y because 3, 3, and 3 are divisible by each other, and I wouldn't get any fractions. But I know that if I can find a 1x or a 1y, I don't have to do quite as much work. And if I take a look at this second equation, I see there is a 1y right there. So let's go ahead and take the second equation and let's solve for y. So that means I'm going to add my 5x to both sides, cross it out, y equals 5x plus 13. So that is now equation number 2. I'm going to go ahead and cross that guy out. All right, so we're going to go back to equation number 1. So negative 3x plus 3y equals 3. And where is the 5x plus 13 going to go? Is it going to go where the x is, or is it going to go where the y is? Well, hopefully you're thinking, oh yeah, it needs to go where the y is because it is a y equals. Remember, we can only have one variable, so we want that variable to be either all x's or all y's. So let's substitute. I'm going to put in the 5x plus 13 and drop my 3, and then let's go ahead and solve. So go ahead and hit pause real quick and see if you can find your x. All right, let's see how you did. Negative 3x. We have a 15x multiplying here, and 3 times 13 is going to give me a positive 39. All right, so now if I look at this, remember you're only supposed to have 2 terms on one side, and I happen to have 3. So that means something has to be combined. There has to be some like terms. So if I take a look at what I have here, I have negative 3 plus 15x. So negative 3 plus 15x is going to give me 12x plus 39 equals 3. Subtracting my 39, I have 12x equals a negative 36, and I'm dividing by 12. So x is equal to negative 3. So remember, when we're solving for systems, we're solving for an ordered pair. We need an x and a y. And since this is my x value, that's going to go in the first spot. All right, so the next step to be able to find my y, I'm going to go back to the equation that I solved for y. Okay, it's always good to use that second equation or the equation that you solved for y or x with to find the other variable, because this means less work. So this negative 3 is going to go in where the 5 is. So 5 times negative 3 plus 13, that is negative 15 plus 13. So y equals negative 2. So there's my answer. Negative 3, negative 2. All right, let's look at a couple more. Okay, so this one kind of steps it up a little bit, and we're going to have to figure out how we can not get fractions. Okay, so this is where you have to think about what numbers are divisible by what numbers so they don't get fractions. So for example, if I give you 10, 5, and 2, we know those are divisible. But if I give you 10, 5, and 3, those are not divisible. The 3 is not going to help me. Okay, so I'm looking for numbers that are going to multiply to either create the other number or something that I can divide and not get a fraction. Okay, because we don't want a problem that has a ton of fractions in them. Now, that doesn't mean you can't solve one with tons of fractions. It just means that it's just more work and we have to clear the fraction. So it's always easier to find one that doesn't have any fractions. Okay, so let's look at equation 1 and let's look at equation 2. So if I look at equation 1, I have 3, 4, and 2. Well, I know that if I divide it by 4, 3 divided by 4, that's a fraction. And 4 divided by, or 2 divided by 4, that's a fraction. So no matter what I do here, I'm going to get a fraction. If I divide by 3, well, 3 divided by 3, I'm okay with that. But 4 divided by 3, nope. And 2 divided by 3, nope, that's not going to work. So I definitely do not want to use equation 1. Okay, equation 2, I have a 3x, a 3y, and a 3, negative 3. And if you notice, they're all the same number. So if I see that they're all the same, a 3, and a negative 3, which really is truly just the opposite, I know that I can use that one to solve for. So let's just solve for x this time, just because we can. So I'm going to move my 3y. So 3x equals negative 3y minus 3. I'm going to divide by 3. So x equals negative 1y minus 1. All right, so we've got a new equation for number 2. All right, and we're going to substitute in for x this time because it is the x. So this negative 1y minus 1 goes right there. Watch your signs, okay? Make sure and don't lose your negatives. Go ahead and hit pause and see if you can come up with the y value. All right, let's distribute. Negative 3 times negative 1 is positive 3. Negative 3 times negative 1, that's positive 3. Again, minus 4y equals 2. Okay, again, there's 3 terms here. So we need to combine like terms. The like terms are the y's. So 3 plus negative 4, that gives me a negative 1. Okay, if you haven't solved for y yet because you got stuck, then go ahead and hit pause again and see if you can solve for y. All right, let's finish this up. I'm going to subtract my 3. Negative 1y equals negative 1. Divide by negative 1, and I come up with y equals 1. Okay, so remember, this is an ordered pair. My solution is the intersection of the 2 lines. So I have y is 1. All right, so to finish up this problem, I'm going to go back to equation number 2. And I know that y equals 1, so it is going to go right there. So negative 1, there's a 1 minus 1. So that is negative 1 minus 1. So x is going to be a negative 2. And there's my answer. So my 2 lines, so line 1 and line 2 are intersecting right there at point negative 2, comma 1. That is where they are equal. Okay, let's look at one more before I cut you loose to do some more work. And this one is a little bit more advanced. And we need to kind of take a look at our numbers and decide what I should solve for this time. Okay? And when we're looking at our factors, we always want to find the smallest factor that are multiples of each other because that one is the one that's going to give me no fractions. Okay? So let's look at our equations. We have equation 1 and equation 2. Let's start by looking at equation 2 this time. I have 7, 8, and 5. And you guys know that that one's not going to work. I can't divide by 8. I can't divide by 7. I can't divide by 5 and come up with no fractions. I don't want fractions. So I know that I'm not going to use that equation. Okay, let's look at equation 1. So I have negative 2x plus 6y equals 6. So I could divide by 6. I see that that's a multiple. And so let's check our thinking here. So if I'm dividing by this 6, I have 6 divided by 6 on the right side. Well, that's a 1. But negative 2x divided by 6, that's going to give me a negative 1/3. I don't want to do that. I don't want the fraction. Well, what happens if we switch that, get my eraser here, and we solve for the x value? So if I have a 6y and a 6 and I'm dividing by the negative 2, that gives me a negative 3, and this one gives me another negative 3. So I'm good there. I can actually get rid of fractions. So this is why you always want to use the smaller of the multiples or of the factors, okay? The 2 is going to be the one that is going to not give me fractions. So we're going to solve for x. So negative 2x plus 6y equals 6. I'm going to move my y. So negative 2x equals negative 6y plus 6, and divide negative 2. So x is going to equal a positive 3y minus 3. Okay, so that equation is now gone. Here's now equation 1. All right, we're going to move on. So from here, go ahead and hit pause and see if you can finish up the problem. All right, let's see how you did. So I know that this is x. So the 3x minus 3 is going to go in this first spot. So negative 7 times 3 is negative 21x, and a negative is a positive. Whoops. This is a y. I got to be able to read my own writing here. Let me go back and erase this and write it correctly. Negative 7, 3y minus 3. There we go. Negative 21y plus 21 plus 8y, negative 5. Okay, again, 3 terms. I need to combine. Negative 21 plus 8 is going to bring me to a negative 13. And for those of you who are kind of struggling solving equations, remember this is times negative 13, divide negative 13, plus 21 minus 21. So I'm going to subtract 21, and I'm adding these guys. So negative 26, drop my negative 13y, divide by the negative 13, and I come up with y equals 2. And that's going to go in the second spot because that is a y. And the last part, to be able to find the solution of the x, that's pretty simple. My 2 is going to pop right over here to the equation that I solved. 3 times 2 minus 3. 6 minus 3 gives me 3. So my answer is 3, 2. Okay, so those are some extra problems to kind of help you figure out what to do with those. And I'm sure you'll have some questions, so please reach out to us with some questions for some help. We are here to support you. Have a good day. We will see you on the flip side where we take a look at graphing, which should be just kind of a quick review of some of the things that we've done before.